The last type of transformation, rigid transformation we'll be looking at is rotations. It's like the other two. Start off with some key words. Rotation, you'll see turn, twist, a couple important things. You can go clockwise, which when you think about the way a clock turns, looks something like that. Clockwise is negative degree amount, which will force counterclockwise to be like that. And this is a positive degree. The notation would be rotate. A degree amount, P, then object, where lowercase r means rotate. The degree amount tells you direction and how much. P is your point of rotation. For this class, it's just going to be the origin. And then object still hasn't changed. So what is being moved? The last rule I want to tell you is that a 90-degree rotation gives us the following movement. XY, so a point XY becomes negative Y X. If it is negative 90 degrees, we still start with a point XY. And all we're going to do here is use this same rule. However, we're going to put this negative out in front, and then we treat it like a math problem where we just distribute. So negative is really positive. Negative times positive is negative, and then X. If you can remember these, or really honestly, this one right here, you can do all types of transformations, rotations, because it's going to be in multiples of 90. So if you have an 180-degree rotation, you just do 90 twice. If you have 270, you do it 3 times, 4 times, 5 times, 6 times. Oh, you give it to me negative? Well, I'm just going to put a negative in front, distribute it, versus having to know 8 or 9 different rules and or formulas. Y'all know I'm not big on those. So starting with number 2 on page 2, rotate 90 degrees. So rotate 90 degrees about the origin, so the point 0, 0. And we have triangle ZJL. 90 degrees counterclockwise tells me it's positive, and I'm going to the left. So again, you just pick a point, Z, which is negative 1, 2, 3, 4. What does it move to? Well, I remember my rule. 90 degrees, which is positive, xy is going to become negative yx. So I take my y value, which is 0. I make it negative. So negative y is just 0. Then x does not change, and it's negative 4. So 0, negative 4 would be z prime. J is negative 5, negative 2. Again, I want to take the point xy, swap their places, make y negative. Again, don't mess up on the sign. I don't know if you saw that. I'd almost left off the negative 2 there. But y value, make it negative or change the sign. So negative, negative 2 is positive 2. X stays the same. So over 2, down 5. And that'll be J prime. And then last but not least, L is 0, negative 3. I'm going to stick with this rule. So 0, negative 3. Change the sign of y, put it at front. X stays the same, but it goes to the back. And then 3, 0 will be L prime. And you just connect the dots to finish it off. This one, we're going to rotate 180 degrees about the origin. If it doesn't tell you the direction, so counterclockwise, clockwise, you need to look at your sign. In this case, I don't see a negative, so I'm going to go to the left because it's positive. And again, or now I'm not going to go or do all 3 of these points. So what I think about is how many times can my rotation amount go into 90? And then 180 divided by 90, which is really 18 over 9, is just 2. So I'm going to do xy to negative yx is my new point. So if I start with h, negative 2, negative 3, change the sign of my y value, put it at the front, x stays the same. So that's 1. I then take my new point, do the negative yx again. So my y value, negative 2, change the sign, put it at front, x value stays the same. So over 2, up 3. And then you would do the same thing for the remaining 2 points. Number 8, rotate a figure negative 270 degrees. Again, if we just stick with the origin, don't mind this P right there. If I take this coordinate, it is 3, 1, 2, 3, 4, 5. Just going to call it A. So negative means I'm going right. 270 is not 90. So divide my given rotation amount divided by 90. That tells me how many times I'm going to apply the 90-degree rule. So 3, 5. And remember x, y to negative yx. But because I'm rotating left, I'm going to have to bring in this negative at the beginning. So negative y is y, and then negative x. So this is my rule. I'm going to do this 3 times. So 3, 5, use the rule yx. So y comes up front. Change the sign of x. So this is 1 time. Take that point. Take my y value, put it at the front. X value goes at the back. Switch its sign. It's my 2nd time. Take that point. Again, y value now comes up front. X value at the back. Change the sign. That's my 3rd time. So this is my answer. Negative 5 and 3. Another way you can think of this, and I may be getting ready to confuse you a little bit, is if I think about this is making right angles, right? To get to that point, okay, had to go over 3, up 5. Now, for math 1, when we wrote equations to lines and made them perpendicular, you just take the opposite reciprocal. So it would be 5, 1, 2, 3, 4, 5, negative 3. Right? And there goes a 90-degree. Now I'm going to do the opposite reciprocal of this. Okay? So 5, negative 3. Or excuse me. So it would be negative 3, negative 5. There goes 180. All right, so that's 90. That's 90. Add those together, we get 180. And then our last one is right there, which is another 90. And I'm going to the right, so it's negative. So if you were good at writing equations of perpendicular lines last year, use that same thought process to do these as well. Again, if that didn't make any sense to you, just go back to the way we did the first couple examples. I'm just trying to give you another option.